Okay, welcome again. This is problem number 605, can place flowers. So this was not my first solution at all, but I'll get into that because this question took me a while to end up here. I had something that was working for most test cases except like five, and it was so annoying. Anyway, so I have a long flower bed with in which some of the plots are planted, some are not. However, flowers can be placed in adjacent plots. Given an integer array flower bed containing zeros and ones, where zero means empty and one means not, empty, an integer n, return true if n flowers can be planted in the flower bed without violating the no adjacent flowers rule, and false otherwise. Here's my thing with this. At first, I thought I was being so smart, so I was like, I don't have the code for it because it was a lot. It wasn't a lot, but like the whole me doing this was a lot. But I can tell you what I did the first time. The first time, I essentially just checked to see the maximum amount of flowers that you can have by checking the length, and then if it was even, the maximum number of flowers you can have was just length divided by 2. That's just like regular integer division. And if you added n to the number of flowers already and it exceeded the maximum amount, then I'll return false. That wasn't checking for the adjacency rule. So it worked for some test cases, but it didn't work for all of it because it wasn't a perfect solution. Anyway, this now, what I did here, I only focus on the adjacency, the no adjacent rule. So I checked when a plot was zeros, meaning it had the potential to have a flower, and then if it was zero, so therefore it did have the potential, I checked if the left was empty and if right was empty. Well, I didn't check here, but this is me declaring what left empty and right empty are. So if it was the first element, like say, oh, none of these are that. Say the first one was a zero, like on the left of it, there's nothing there. So left empty if this is the case. Or if there actually is like one of these and I could actually go back and check. Because if I just had this, if I was zero, boom, error. The zero minus one is what? Minus one. Let's program here. Come on. Then I did same check right was empty. If right was the last one, that's what this is. Cool. Now if left empty and right empty, then boom, we place a flower. We minus one from n because that's one flower placed, and then we keep it pushing. If it's not equal to zero, so it's not a place we can put a flower, we just skip it. We just keep going. A flower's already there. We don't talk about it. Oh, but this one here, this makes it so that we skip the next one. Because if I put a flower here, the next spot cannot have a flower regardless. So we just skip it one time. And I return n less than or equal to 0. So it's because if n is less than or equal to 0, that means all the flowers were placed. So we good. We good with that. Let's run. Not run. Yeah, run it one time. Cool. Nice.